This is the SpaceX rocket. Even this also works under same principle, action and reaction. So this part which you see, this one, it will be action for this one, and this action makes reaction as moving forward or upward direction. So these are action reaction pair. Can you all hear me right? Or am I not audible?
You're audible.
Audible, right? Okay, fine. So in short, this all, whatever we studied, this one, law of conservation momentum. This is all law of conservation momentum, action and reaction pair. So it's all based on principle. Which one? Newton's third law. Where is it? Yeah. Every action, there is an equal and opposite reaction. Let's do some numerical so that it'll be easy to understand more. Yeah, by the way, can someone tell me what is the significance of today's day? Like there is Science Day, okay, but why? Why today we have Science Day? Do anyone know?
So is it related to C. V. Raman?
Exactly. Today he got Nobel Prize. Then when is International Science Day? Yeah, when is International Science Day?
That's somewhere in November. I remember.
Yes, somewhere in November. Can you guess the date?
So 5?
Add 5 more.
10.
Yeah.
Okay.
Mass of 120 kg and is traveling at 2 meters per second. While the other has a mass of 80 kg and is traveling at 4 meters per second. What's the first? Oh, nice. Question is good. Come on. What they're saying? Can someone explain?
So shall I?
Yeah, sure.
So they're saying that there is two players. Each one is 120 kg and is traveling at a speed of 2 meter per second, while the other plays 80 kg and is traveling at the speed of 4 meter per second, and they collide. So what will the speed be after they collide?
They are saying they become entangled.
What is the meaning of that, sir?
Entangle means like
They get stuck
stuck
between each
in
other.
each other. Yeah,
So
stuck
then
to
they
each
won't move, or they'll move too fast and hit their head, sir.
other. That's what the question is. Okay, so one hint for you: use the above formula which we wrote. Where is it? Yeah. M1 U1 plus M2 U2 M1 V1 plus M2 V2. So M1 is of mass 1 of first object, M2 is for mass for second object, U1 is the initial velocity for first, U2 is the initial velocity for second. So both left side are initials, both right side are finals. Try it, no googling. Anyhow, I will give you answer. I'll solve it. First you try it. It's very easy. Just formula, substitute values, get the answer. Over. Nothing big here.
Sir, but when we are applying that formula, what exactly are we getting?
We are finding the velocity of both players together, right?
Oh, okay, sir. So
Because
then,
they said here they entangle. Immediately became entangle. One has mass this much, with this one, this much, and with this much speed. So it moved towards the first, and what speed do after they become entangled? Means together they are moving now.
They both will have the like same
Same velocity.
value.
Yes, very good. Come on. Second hint you already got. First hint I said use formula. Second hint I said, oh, I didn't. You gave that is true. Now find out. Now you should get answer. Anyhow. बोलो बोलो आंसर बोलो. So what you have taken first M1 as 120 or 80?
120, sir.
Okay, you have taken M1 as 120. So let's make a list. Oh, okay. So this, read the statement properly, okay? What they're saying. He's moving towards the first player. Don't forget that line. Second player traveling at 4 meters per second move towards the first player. Excuse me.
Sir, will the speed be 3 point something something?
3 point.
I have to solve that 3 point what?
Yeah, okay. 3 point something. What's a fraction?
Fraction was 13 by 4.
13 by 4. Uh-huh. Check again. You did some calculation mistake, maybe. Or read this statement which I have highlighted. Traveling at a 4 meters per second towards the first player. Come on, I want correct answer from you all. So what, Satvik? Are you there?
Yes, sir, trying.
Trying? Good. Pulastya? You're with us? Okay. Devshika says 23 by 13. Decimals will be 2. 0.2 something. Okay, let's see. Vivek?
Sir, I'm trying, sir.
Okay, and Yukta? You too? Yukta Shri? Are you also trying?
Yes, sir.
You need option E?
Now I'm doing it.
Good, good. Okay, you do. I'll drink water.
Sir,
Yeah, I'm here. Say?
sir, oh yeah, sir, is it what is it 80 divided, wait, is it 80 divided by 200?
Okay, so decimal will be
Yeah, I'll just 8 divided by
8 by
20, that's
20, 4, 2 are 4, 5.
that's
Yeah,
0.4.
yeah. Yes,
Is it correct?
yes. Very good. Super,
Oh,
super.
sir.
Sir, could you solve it?
Yeah, sure. I'll solve. Just a second. I'll just drink water. Okay, then. Anybody got same or anything difficult? Okay, no problem. So let's go with the formula. M1, U1, I'll just substitute values. Let's substitute values directly. So 120 into 2, right? Plus 80 into, this is minus 4. Why?
Oh, it's going towards the player.
Oh, there is one the
Oh,
mistake,
yeah, yeah.
sir.
Got
Right.
it. Got it.
So this both V1 and V2 are equal. So let's name it as V, which is M1 plus M2. So 120 plus 80, which is 200, and 120, 240 minus how much?
320.
20, right?
Fine. Yes, sir.
Which is 200 V here, 40, 60, 80. 80 divided by 200, which is V. V equals to minus 2 by, I think so, 6, 40, 42s are and 45s are. Minus 2 by 5. If we divide furthermore, minus 0.4
4.
meter per second.
So just in that -4, it all went.
Wow,
Yeah.
that -4.
Yeah, see, that's why I highlighted traveling towards. Right? Easy?
Sir, is this like this is how the questions will be asked, or this is something higher than what it will be asked?
These are like Olympiad questions.
Okay, sir.
Mostly I'm solving in your class. Those are Olympiad questions or some like up to your level, whatever questions are there. Olympiad or NTSC. Because for NTSC and Olympiad, you have to prepare for everything up to your level. You won't get differentiation integration as we discussed last class. It won't be that much. But up to this type of question, these are just easy. I'll give you some more tough. Okay, first sorry?
No, sir. No, sir. Mistake.
No, say what?
Sir, no, sir. I didn't say anything. It just got unmuted. Mistake.
Acha. Okay, no problem. Fine. Let's do one more question like that. A bullet of mass 0.01 kg fired from a gun (5 kg). If the speed of (250 meter per second calculate the speed with which the gun recoils. So what we are going to do here? What will be M1, M2? What will be M2, M3? What will be V1, V2? What will be U1, U2? Come on. Who will guess these things? Come on, tell me. Okay, let me ask randomly someone. Okay. Miss Silent Girl, Yukta. Yukta Shri? You there with us? No? Knock, knock. Okay, Vivek?
Sir, is M1 0.01 kg?
Yeah. By the way, Yeah.
Oh
Yes,
no,
please,
wait
sir.
a second. Wait a second. I'll just do it again. I made a mistake.
Yeah. So Vivek, like we can take anything as M1
Sir,
and
is
M2.
it 0.5?
Sir, is it
0.5.
minus 0.5?
Sir, is it 0.5?
Okay, it might be.
Sir, it's minus 0.5.
Okay, so what are the values you took? Tell me.
Sir, I took M1 as 5.
Okay, let
and,
me write. 1 second. Let me write. Otherwise, I'll forget.
I just got 0.5.
M1 is 0.01.
I took M1 as 5 and M2 as 0.0.
Okay, doesn't matter. M1 is 5 kg. Means this is your gun. This is bullet. Done.
And
You
then
took
5 into V plus 0.01 into 250 is equal to 0. And then
But what about initial velocities?
Sir, here we don't need to prove like
initial velocities will be 0, no?
Why?
But I don't know.
Why you thought of 0?
Because like it's already not, it's not moving already before it's being fired. It's like, it's 0. It's not moving.
We can say, yeah, bullet is at rest.
Yes, sir.
Yes, correct. It's correct. So bullet at rest. 0. Oh, bullet is here. Sorry. What about gun? Is gun moving anywhere?
No, sir.
Not moving. So even it is also 0. So we are left with V2, V1. So speed of the bullet is 250. Where is bullet? Here 250, right? Meter per second. So we need to find out V1. So M1, U1 plus M2, U2, which is this whole term is equals to 0. Both are zeros. So that's right, only this right side term. So M1, V1 plus M2, V2 equals to 0. So M1 is 5 into V1 plus M2 is 0.01 into V2, that is 250 equals to 0. So yes, it should be minus 5V1 equals to 0.01 into 250 divided by 5. Did I miss anything? Or 1 kg? Right. So it should be 120. So 2.5. Yeah. Answer is correct. 5 means 0.5 meter per second. Minus. So yes, gun will have recoil of 0.5 meter per second. Negative shows reverse. Easy?
Yes, sir.
Very much easy, right? Shall we do some tough question with this?
Yes, sir.
yes, sir.
Okay, let me find some. Okay, first let me finish one more topic of this chapter. This last topic. Then we can do all numericals. We have so much time. That's free body diagram. It's very small and easy when very interesting. Free body diagram. And this will be useful for like everything. Wherever you are forced, you can draw this and manipulate your question. Okay, so free body diagram means at an object, suppose I'll give you with example. The object is lying on the floor. So what are the force acting on this free body diagram? It shows like in the object is lying on this one. Free body diagram shows just forces on that object. Okay, on forces on the object. Suppose there is a force which is downward, which is mg. We wrote that there, right? Weight equals to mg. Weight always point towards where? Don't remember? Weight always point towards. Nobody remember that?
So could you repeat what you're saying because your voice is breaking?
My voice is breaking. Okay, I'm asking that like where weight will be pointing always towards the from the center where it will go. How will I say that there is a weight here? Weight, force, or gravitation
Towards the ground?
towards the ground, center of the ground, right?
Yes, sir.
Yeah, and normal force.
Perpendicular to the object.
Yes, perpendicular to the object. So this, what we are drawing, this one is your free body diagram. Just for showing forces, that's it, nothing else. Let's draw free body diagram of something. Yeah, let's draw for this one only.
How does this help, though, sir?
Now, if this was simple, right? If it is like at some angle apart, at this one, suppose this way. So if I want to measure a force acting on this one, so there will be so many forces. So how to calculate force? So what I'll do, I will just distribute all the forces. Then I have to just draw where force act and I have to equate this. Like this normal force, we drew here normal force, right? If I want to find normal force, that is equals to mg because it's balanced.
Yes.
Now this forward force which we are pushing, which will be equals to friction force, which is moving backward. Okay, but there is one more force which is mg, and suppose this is an incline, theta. So as this is an incline, and there will be some more force with this, that it will be at some angle. The force is at with angle. So we will use the angle and simplify this. So how this will help for, like, we don't know what are forces, so we will equate directly. We can equate here, forward force should be equals to backward force, that is friction. This is applied force equals to friction force. So F equals to F. And here normal force equals to mg. So if by equating, we can find out, okay.
Sir, can I reopen the meet?
Yeah, sure. In short, like what we are doing here, how much force I should apply to overcome this friction. We want to know if this is a box, how much force should we apply to overcome the friction. So by this free body diagram, it will be easier to calculate. So in short, this one in free body diagram, those are like equal and opposite forces. Normal is equal and opposite to mg. For applied force is equal and opposite to friction force, and so on. If I draw some complicated diagram, let's see, some wall, let's make a brick wall. Okay, this is the brick wall. And some ball is tied here. Or some weight is tied here, attached with the string from the center. So if I ask you, what is the force on this ball? Like, what is the force acting on this one? So if I just say there's a force on ball due to this object, there is wall. Let me change the color. Force on a ball due to this one, that is normal force, which will be opposing to the normal force of the wall. Okay, internet. Okay, so where were we? Okay, so this is normal force acting equal and opposite to this. To normal force due to this ball, normal force due to the wall. And this is a string, means rope. The ball is tied with a rope, so there will be tension force. Tension force. And this is weight mg as usual towards the downward. Are you able to understand?
Yes, sir.
Sure.
So once again.
So once.
Okay. Yeah, don't feel shy to say no. I won't scold you. Obvious. Okay. Now see, as we say, there is normal force, right? So normal force will be acting everywhere. But why I particularly drew here? Because normal force acting everywhere, no problem. But here we are considering ball. So there should be one opposing force which is holding him. And there should be one more force which is towards the wall. So from the wall and towards the wall. So there is from the ball towards the wall. This is your normal force. Anyone wall will possess some normal force which is opposite to this one. It should be here. But if I drew here, it will be like complicated to understand. So I'm drawing here. Consider this one at this point here. Okay.
Okay, sir.
Yeah. So two normal forces, equal and opposite. Then one mg, which is weight or gravitational force or force due to gravity, and one force from the string because it's tied here. So from tying, there will be one more force, equal and opposite, that is tension force. So whenever rope, when you see rope or some string or some attachment like that, there will be tension force, tension in a string. So tension is also a force. If you remember, tension is also force, which is created by that itself, that a string or rope or whatever it is, chain, it is created by itself. So when we swing, you feel some force in that. When you swing, when we're playing with some rope or a spinning top, when you're playing, there is a tension in that. So this is tension force towards the direction of wall because it's tied there. So if I draw just freeboard diagram of this one, this looks complicated. Now it will be easier. See, normal force, mg, normal, and one tension force, T. That's it.
Okay, sir.
Yeah, just I'm showing you how to draw free body diagram. I'm not asking you to calculate this because for that you need to learn some trigonometric function. So we just drew free body diagram. This is your free body diagram. Here we can find, with the help of trigonometric function, we can find out this one and this normal force, everything. Okay. Let's go with some contact force. Means when two objects are in contact. Suppose, let me draw two boxes. One, two, and three. So two box. Okay. Let's name it as M1, M2, M3. Now three boxes are there. If I'm applying force here, will the acceleration same for all three? Will the velocity or force between them will be same? Can you say something about that? Will the velocity, force will be same for between two boxes M1 and M2 and M2 and M3? Or will the
No,
force
sir.
be same? Yeah.
The mass is different, sir. So
It will not be same.
Okay, let me write question, what I'm asking. First is acceleration. Overall acceleration. Second one, force between, let's take it as 1 and 2, and between 2 and 3 will be equal. Okay, now you can answer. Think of this question.
Sir, it might be equal because the part in contact is the same between mass 1 and 2 and 2 and 3.
So you mean F12 and F23 will be equal?
Maybe.
sir, I think F12 will be more than F23.
Okay. So what about acceleration? Overall acceleration? It will be same for all three or it will be different for all three?
So it will be
So it will be different.
Yes, Vivek, it will be different. So
Yeah,
can you
sir.
spot some reason?
So maybe the size
Maybe
or
size,
the weight.
weight. Okay. So if you have three books together, keep it right now, or three objects together, keep it right now with nearby three object, any object. If not eraser or something, three object, and apply force. Are all three moving together? See? Do it practically and tell me.
yes, sir.
Yes, Yukta, what do you think? Satvik?
Sir, even though they move equally, I mean, together, sir, chances are there, not chance, the first object can reach the target in the different time motion. Time differs, right?
Okay. I don't have any something here to show. Okay, fine. Yeah, you are correct. But see, when we are applying force on the first object and second object and third object, they are together. So if I'm pushing on the first object, so will all the object moves together, right?
Yeah, sir.
Yes, sir.
Yes, Satvik, what do you think? Will acceleration be same for all three, or it will be different for first and last?
So I think
I think.
no, wait.
Okay, wait.
Can you repeat the question once?
Yeah, as you see here, like acceleration will be same, overall acceleration for all three.
Yes.
Will it same? Okay. And what about this forces between them? Will it be same or it will be different? Okay, then let me prove it and show you. You are correct or not? You can tell me after this proof. Let's start with the first one. When we are finding acceleration, let's start with the first one. Let's name it here F12, F23. So this force acting between these two, this force is acting between these two. So difference of F minus F12 will be equals to this force, what this is handling, that is M1 into A. For M2, this is for, let's take box 1. Let's calculate for box 2. M2 is there. So what are the force acting behind him? F2 on the left, sorry, F12 on the left and F23 on the right. So let's subtract them. F12 minus F23, which is equals to M2A. Okay, then for third object, only F23, which is equals to MA. So overall, A equals to, we can say, force by M1 plus M2 plus M3. So overall acceleration is similar. Now, as we saw here, by this equations 3 we saw, let's find out F12. Now, think of F12. Now, see, what first object has to do, suppose, think that we are sitting, we all are 3 objects, okay? And I'm one, you're second one, and someone is else third one. So if someone is pushing me, so he has to cover, this force has to cover M1, M2, and M3. Now, if I am pushing whom? These two, M2 and M3. So I have to cover these two forces. Now, M2 has to cover only M3. That means overall force F, which we derived here, has to be for 1, 2, and 3, all 3. So we can write here A, that's what we got here, F equals to M into A. So M is M1 plus M2 plus M3. So this is for total force applied. Now I have to apply, means I am the M1. So I have to apply less force, which is between M1, F1, F12. I have to apply F12, and someone else will apply, let's take Satvik will apply F23. Okay, so F12. So let's calculate. Okay, you give me values. Come on, F12. I gave it for F. So you give me F12, Satvik. Satvik?
Yes, sir.
Yeah, you give me F12. I said F equals to MA. M is total forces, total masses, sorry. M1, M2, M3. So F12 will be Yes, Satvik?
Sir, I don't.
Guess it. See, that means you didn't understand. See, I'll explain this again. Force, total force applied. That is F. So F has to do work, or F has to apply force for M1, M2, and M3. Total force. So when we are finding this total force, we will add all the forces and multiply by acceleration. Now, M1 has to do, or M1 has to push, or M1 has to apply the force for remaining two.
M2, M3.
Yes. And M2 has to push M3. So that is force of 2, 3. So F12 force, F23 force. F12 is for M2 and M3. F23 is for M3.
Yes, sir.
So guess the value for F12. No idea?
No, sir.
Okay. That is for M2 plus M3, which is equals to A into A. Mass into acceleration. Then F23 equals to M3 into A. So what is A? This value. What is A here? This value. Understood? Okay. What about this? Bhumika? Deepshika?
Yeah, sir, understood.
Yes, Vivek. Good. What about Deepshika and Bhumika?
Understood, sir.
Yes, I understood.
Okay. So these are connecting bodies. What will happen when bodies are connected? M2 plus M3. I can write this one as F by M1 plus M2 plus M3. Same way, M3, F, M1. That's okay. Let's have some question.
Okay, sir.
What happened? You all become tired by seeing something new?
No, sir. It's just processing.
Processing. Acha. Moves at a constant speed of 10 meters per second. What happened? Everyone left? Amalo? Do you have another class right now?
Sir, at 7:30 we are having.
Acha. So there is no one here? Only you, me?
Sir, I'm also here.
Ah, you're also there. Okay. x for 4 meters per second. No, 4 seconds. And use it. Force acting on the is. Oh, we have option here. Option A, minus 30. Three Newton. Option C. Again 3 Newton. A printing mistake. Let it be. Then I'll keep 30. Option D. Try this as a homework. Okay.
So there is homework.
Yeah. Try this as a homework. I'll give you one more. Or is this enough? Yeah.
You can give, sir.
You can give, sir.
Okay. No Googling, okay? You try yourself.
Sir, can we get these notes?
Notes for this one? Yeah, I'll update today.
Okay, sir.
I didn't do it since 2-3 classes, right? 2 classes, I don't know. 3 classes.
Yes, sir.
Meter per second. Forces require. Keep the gun in position. Ten Newton. $15 Newton. Okay, 30 Newtons. I don't have answers for this. You have to solve this. Once you get answer, we will solve here itself. Written?
Yes, sir.
Yeah, sir.
Deepshika? Done?
Yes, sir. Yes.
Okay. Okay then. Bye-bye. See you on next class with the answer.